Good morning, everybody. Thank you for joining us for this next edition of our Kong webinar. I'm joined today, my name is Cooper Marcus. I'm the Principal Product Manager here at Kong Inc. And I'm joined by Aaron Miller, our Senior Solutions Engineer, and frankly, star of the show.
No, Cooper, you're the star of the show.
No, you are. Well, anyway, enough of that silliness. Let's get on to the real meat of the issue here. Today, we're talking about improving your microservices, and heck, really, it works pretty well too for monoliths with Kong health checks and circuit breakers. We'll be showing off some new functionality recently released in both Kong Community Edition and Enterprise Edition, and we'll be demonstrating to you how you can easily set up health checks and circuit breakers to improve the reliability and performance of your services to your clients, regardless of whether your clients are external API consumers, internal applications, even other microservices. This works equally well in all situations. Is that the preamble? Let's dig in.
Yeah. So before we get started, let's give a little bit of kind of the evolution of API gateways and software in general. You'll notice on this slide, way back in the olden days of, before 2008, we had a number of websites, and they exposed a number of services, and they were useful. You could buy things, but they were, somewhat heavyweight. It was just enough to expose services on the web back then. Things bump along, you get mobile apps, you start to get more corporate platforms, and you start to see purchasing and e-commerce start to take over. But notice an inflection point right there around 2014. Something interesting happened to the ecosystem, and that was really a product and a platform and a way of delivering software that gave software wings. This is the Docker release. So it finally enabled us a way to release services that made it super fast. And in fact, today I'm going to be using a few Docker containers to run this, because it's so easy to spin them up and get them up and running, control them fully, and then I'll stop some of them and we'll see health checks and circuit breakers. So Docker and containerization is a little bit of a double-edged sword, though, because you can imagine now you've unleashed all your developers and they're spinning up containers all over the place. You also have then a plethora of services that you need to keep track of.
That's
and
right.
If one of them goes down, well, if that's a critical payroll or billing or customer lookup function, what are you going to do? You're going to kind of bring down your whole thing. And, you might think, oh, great, I'm not using a monolith anymore. I'm using all these web services and they're all running in containers, but you don't necessarily have a way to keep track of them. And health checks and circuit breakers are really an enablement for that. And we'll show you some of that working with Kong later on. So another way to think about this, and because we'd like to have lots of metaphors, is think about what it takes to run a city. Most of us probably commuted into a city today, and if there's something going on there might be an accident, there might be construction. One of the main arteries into a city might be shut down. That doesn't mean the whole city stops. No, you just route around it. I think of a health check and a circuit breaker in much the same way. You just need some way of identifying where the detour is, and inform your people that are driving into the city where to go elsewhere, and we can do that in software as well.
That's right. I mean, imagine the difference between a construction crew showing up and digging a big hole in the middle of the street with no signs, right? No warnings, no detours, no nothing, and the traffic just piles up behind them. There's down to one lane, right?
Yep.
Health checks and circuit breakers are about detecting that crew, putting up the signs, rerouting the traffic, and doing it all without you, the administrator, having to do the work to manually detect those things, manually reconfigure those things. Let's make those computers do the work for us.
Exactly. So moving along, another metaphor. And we're trying out a new one here. So if you're familiar with Kong, this is where we usually have a chicken, but we're trying something a little more sweet, I would say. Happy Valentine's Day to everybody. It's not so much that you can't serve a cake and serve up cupcakes at the same time. It's more that your business that only made cakes before, needs to kind of branch out and make things a little bit more consumable by people. And also, when you switch to a cupcake model, you can offer many more flavors. You can add, if chocolate is popular on a particular day, you can spin up more chocolate cupcakes. You can't necessarily do that with a full-on cake.
And I was thinking about this picture overnight when I was home with my kids, and I was reminded that if you drop one of these cupcakes on the floor and it ends up face down and no one wants to eat it, it's all hairy now, like, it doesn't matter. You've got a bunch of other ones, right? Hey, you've got more cupcakes, no problem. You drop that delicious looking ganache wedding cake over on the left on the floor and you are in big trouble. So this is about sort of splitting up the responsibilities to the point where any individual cupcake, no biggie, right?
Yep, exactly. So one of the dilemmas that you have when you have a giant cake world or a giant gallon of ice cream is how do you kind of divide that up and decompose them and serve it to people? Well, a simple solution to that is just scoop out little parts of your giant service and approach it that way. So that's what this ice cream scoop analogy is going for. And you can do the same thing with your monolith, right? You can take a giant Uber monolith, which they had this problem in the past, and they fixed it through microservice architecture, and they basically just carved out little services one by one. And we can all do the same thing, right? So the simplest way is to put a load balancer in front of your monolith, and then you can just spin up new instances of your monolith, but it doesn't really solve the root of the problem.
Now, in this picture, we show a client over here on the left speaking to microservices on, what will become microservices on the right, starting with the item service. But as we note there, like the client, it could also be another service, right? And indeed, in the microservices world, there are many service-to-service communications. You have many more hops, many more source and destination, and many more opportunities for failure or poor performance to impact the ultimate end user's experience. And so as we walk through this decoupling and this story about using health checks and circuit breakers, I find it really helpful to keep in mind that we're not just talking about one client and one service typically. We're talking about lots of things, talking to each other, all in an orchestrated fashion to deliver that end user experience, many more points of failure, which means the value of improving the reliability is much higher. All right, so many more places it could fail. Now it's all automatically getting addressed, more valuable. So
yeah.
let's talk about what's going on here. So we've carved out the items microservice.
Correct. Yeah. So you have a team exposing that. Now, of course, they have to implement security, authentication, all of the typical features that you've traditionally offered. And each team does this, right? So you carve out items, you carve out customers. You can see where this is going. Each team is going to have to either re-implement or redeploy a library of these kind of common functionalities. Before you know it, you've got a lot of fragmentation across your stack. And there's a fairly simple solution to this, and this became pretty obvious in the late 2000s. So go ahead, Cooper.
And this fragmentation, all of these yellow boxes over here on the right, they're wasteful, right? We're implementing the same sort of authentication and security and logging and other type of logic, each microservice at a time, but it ends up being pretty darn similar, wasteful for your engineering teams to have to keep doing it. Also, added risk. One of them does it sort of wrong, and now you've got things working inconsistently or not working at all.
Yep.
It seems like there must be a better way, Aaron.
Yeah, of course. You can consolidate all of it, right? And this is a fairly, obvious solution to it. I mean, abstraction is a great way to solve everything in software, right? That the problem it then exposes is that the gateway became somewhat heavyweight. So, back in, 2005-ish era, this was the pattern, right? Everything, all your logic was in the gateway. They tended to be, ESB based, and they were heavyweight, but they worked as long as you just did one hop in between your service and your client, right? But what we saw, and this is where Kong comes in, is that by lightening the layer that you have, basically approaching it in more of a micro gateway architecture rather than a big heavyweight gateway, You can then expose many more microservices, go back and forth between your gateway and your other microservices, and not incur that heavyweight penalty. And that's really what the design of Kong is all about. Make things super fast, have a plug-in architecture so you can choose what parts of the gateway you're going to implement, and only use what you absolutely have to.
And indeed, this sort of plug-in, easily configurable, lightweight, high-performance architecture becomes just a total necessity if you want that speed of innovation, that agility that you get with the microservices, because it's just impossible to reason in some waterfall planning fashion about how you're going to configure that big monolithic API management layer over on the left. You don't know. It's going to be different next week than it is this week. That's okay. That's agile. That's innovation. But you need to have API management layer that can keep up with you.
Yep.
And Kong was built from day one to keep up with the fastest, most innovative teams and organizations.
Exactly. But of course, again, circling back on health checks and circuit breakers, you also need some ability to keep track of all these microservices and their health, and route around them when one of them gets a little bit unhealthy.
That's right.
So this is the design of the Kong API gateway, right? As we mentioned before, plug-in architecture to implement all of your kind of formerly duplicated logic, put it into a single area, have a very, very thin, lightweight, high-performance layer, and put that in front of all of your back-end services so that your clients, customers, partners, other microservices can consume them. Again, I want to emphasize that Kong helps you reduce the fragmentation that you would formerly have if you re-implement all this logic on your own, but not incur the heavy penalty that the initial kind of first wave of API gateways hit you with.
That's right.
Also, looking into the future, what we're looking at is, in this slide on the right, it's a sidecar deployment. So in a future kind of service mesh kind of world, you're not going to go back and forth between a gateway at all. But the gateway will just be a tiny little microservice that sits right alongside your microservices. Nobody's really quite there yet, but Kong is preparing you for the future, and we're getting ready for that ourselves. So to go back, we can centralize your common functionality that's required to deliver modern architectures today, dynamically load balance things, service discovery, authentication, security, on and on and on. You can expose public APIs, partner APIs, functions as a service, private APIs.
And you're exposing them to clients of all sorts, employees, internal systems, microservices, partners, folks in the public, people you don't even know yet, right? Getting yourself ready for the future because the business innovation, the agility that your management demands is going to come from you being able to say to them, when they say, hey, can our API do X? Can we start serving Y? You need to be able to say, yeah, I'm on it, right? Let's make it happen. Now, I just want to remind folks, we have a Q&A feature here in GoToWebinar. Please send in your questions, your comments, your requests for future topics. We'd love to see your questions come in on the Q&A. And this webinar is being recorded. We'll be distributing the recording afterwards to everybody who registered, whether or not you're attending. And we'll be adding it to our konghq.com/webinars page on our website, where you'll also find out about future webinars. As we go, please keep those requests for future webinars coming into the Q&A. We'd love to give you a webinar that you want next time, and it just might happen if you let us know what you'd like to see. All right, Aaron, let's keep going.
Yep. So we want to deploy Kong as widely as possible. So it comes in a couple different flavors. We have a community edition, which is the most widely deployed open source API gateway in the world. Over 15 million downloads, built on top of the world's fastest web server, Nginx, which is pure C web server. Because it's open source, we've had a lot of contributions from the community in terms of adding plugins. Plugins are easily written using a language called Lua, which compiles to a JIT language, and it's coming out of the gaming world. It's just blazingly fast, and it's a lot easier to customize using Lua than it is to customize using C, and that's why we have the open REST Lua layer there. We'll have a sub-millisecond response time for most use cases, which probably is why Kong is so incredibly popular. Because APIs have a special use case in that they must be highly performant, otherwise things slow down pretty quickly. Kong deploys on-premise, and that's why we are so platform agnostic, right? So we deploy to just about anywhere you need to run your servers, and then can interact locally with that service. However, not everybody's needs are met by the Community Edition, so we have an Enterprise Edition as well. Enterprises tend to be, much larger organizations. They have much larger, financial responsibilities to their customers. They just have different needs than community users have, and Kong has an edition for them as well. Just a quick overview of what Enterprise has that community doesn't have. Much more security features and functionality, GUI features built into it, a developer portal, analytics, and of course our outstanding customer success team.
And the CS team, access to our customer success professionals, our colleagues around the world, is a big part of the value of Kong Enterprise. They're not just support folks. They're there day in and day out with our Enterprise Edition subscribers, providing them guidance, advice, future-looking suggestions on not just how to use and leverage and maximize Kong, but how to think about their microservices architectures and how to think about their deployments for the future that will make sure they stay at the cutting edge of agility and performance in delivering new market-leading functionality.
Yep, definitely. So to make Kong, additionally valuable, we have a plugin architecture, as we mentioned before. And there's many plugins. We mentioned 60 plus. This is just a selection of the authentication ones. I would say we're seeing a lot of interest in the OpenID Connect plugins, but of course, the first thing that every API program administrator does is probably implement some form of authentication. Also, because we want to make it extensible, we also want to keep it simple. So we have a very approachable API, and you can either administrate Kong directly from the command line like this, or use the admin GUI in case of the enterprise product to do it. We have, like I mentioned before, platform agnostic. You can deploy pretty much anywhere. I've even heard of people doing it on a Raspberry Pi, so that's an interesting deployment. And today I'm actually going to be showing you the Docker deployment. You won't even notice it, and it runs under the covers. Very quickly, a technology overview. As we mentioned before, Kong is built on top of Nginx, world's fastest web server. To make it extensible, there's the open REST layer, and that enables plugins. To store all of the plugin configurations, you need an area to do that, and that's either Postgres or Cassandra. Depending on your needs, you can choose one of those sources. And then to administrate it, you can access it through the admin API or the admin GUI, and then we're exposing a developer portal as well. Moving right along, to keep things simple again, the default ports for Kong are just these 6 up here, and really, if you're using Community Edition, just 4 of these. And if you really think about it, the bottoms, the 8443 and 444 and 8445, those are just for SSL. So you're typically going to be interacting just with 2 or 3 ports. And to keep the API approachable and simple, there's really 3 core entities: APIs, plugins, consumers. I'm actually going to be demonstrating the upstreams endpoint today, so that'll be a little bit different, but it kind of fits all together with the other entities here.
Now, in a future release of Kong, and possibly in our very next webinar, we'll be looking at an exciting expansion of the API entity into routes and services. We're looking forward to telling you more about this. I think we have a little bit of information out on our Community Edition repo right now, and we're looking forward to a preview experimentation release coming up soon. But these simple, consistent entities are very helpful when sort of reasoning about Kong, thinking about how to configure it, and also when making it work with your system, right? We tend to be very unopinionated about how Kong should be implemented, and so we try to give you just enough of the right core entities, the right amount of functionality to make it work with your microservices, your monoliths, and to make it all work via administrative API calls, which we'll be showing you today, mostly via an administrative GUI that just sits on top of our administrative API.
Yep. So going back to the topic of today's call, let's start with what is a circuit breaker in the first place, right? Well, as we mentioned before, if there's a problem, right? So you have a microservice, it's misbehaving in some way. First of all, the 50% of fixing a problem is acknowledging that there's a problem in the first place, and we can do that with a health check. With the health check, you've now detected the problem. Well, it's great to know that I'm healthy or unhealthy, but then I have to do something with that knowledge. And what am I going to do with that? Well, I'm going to actually break the circuit to that service. So imagine, if you don't have this, what happens, right? So let's say you just have a misbehaving database on your service. Well, each time you're going to call out to that service, you're going to have to trigger and wait for some sort of timeout.
Or maybe it's just slow. Maybe it eventually responds.
Maybe. Yep.
Or it's throwing errors that another instance of that same service is not throwing, and the Kong is returning those errors back to your client. But there's another instance of the service that is healthy that could be serving those requests faster, more reliably. Let's make it so that Kong can tell which instances are healthy, break the circuits to the unhealthy ones, and continue routing traffic to the healthy ones so that your clients get more consistent, more performant responses.
Yep. And this does a couple things for you, right? Imagine it's like throwing up a detour sign around that, construction of that road, right? It lets the construction crew focus on their work that they need to do to fix that road, and it lets the people that would normally drive down that road know that not to take that road and where to go to find the correct road.
That's right. Yeah.
So again, why would you want to do this? Well, as you decouple your services more and more and more, you have more moving parts, you have more streets and roads to manage throughout your city. You have more things to administrate. Isn't it nice to have some kind of automation around that and have automated rerouting, automated detours built in? And this lets you deliver more reliable services, right? You're up more of the time delivering the data that you need to deliver through your APIs.
Now, implementing health checks and circuit breakers with additional tools has certainly been possible for a long time. The innovation we're really bringing to you today is that now health checking and circuit breaking functionality is built into Kong. So you get to remove a layer. There are now fewer moving parts, right? You have more decoupling because you're moving to microservices. So you've got more services to deal with. But let's not also force you to have more infrastructure components to deal with. This new functionality allows you to have less, right? Now Kong is not only routing and load balancing across your upstream instances, but it's also health checking them and making sure that it's only routing requests to healthy instances. Previously, you would have had to have a layer in between Kong and your upstreams that would have taken care of that. Now you don't.
Yep. So let's see what that looks like in a kind of semi-graphical way. I'm running an HTTP bin container and then a duplicate of that container just on a different port to kind of simulate two different servers. And if one of those containers goes away, simulating like a server crash or a disk issue, something like that, well, then it's indeterminate, what happens to the traffic going to that service, right?
Well, that's right. The client maybe just keeps trying. It doesn't know. It gets a slow response. It gets no response. The client has a hard time figuring out what to do in this situation.
Exactly. So let's see what this picture looks like with Kong in the middle, right? You now have health checks and circuit breaking capability here. If HTTP bin service goes away and you break that connection, I can reroute all that traffic to the other service.
Now, this was totally transparent to the client, right? The client is just making requests. Kong is accepting those requests and routing them appropriately. But now what you've resulted in the previous scenario, some of the requests, I don't know, were slow, were never served at all. The client was getting a poor quality of service. Now in this scenario, with Kong performing the health checking and circuit breaking functionality, the client's experience is consistent. it's getting good responses the whole time because Kong is taking care of putting up that detour sign and shifting the traffic to a currently healthy instance.
Yep. Now you of course still have a little bit of work to do. You've got to go back in and fix your other service, but you're not dead in the water by any means. So how are we going to show this, right? In a minute, I'm going to set up 2 APIs. Really, I can do this with 1 API, but I want to show you what happens with one of the APIs when I call the service directly. And then I'm also just going to set up a service as an upstream inside of Kong, and then inside of that upstream, I have 2 targets, and that's where we're going to kind of see the behavior of rerouting to the healthy target. Without the health check and circuit breaker, I can call that service directly. You'll see that fail. And then with them, you'll see me automatically route all my traffic to my healthy service.
Now, just to clarify some of our terminology here, when we say an upstream, what we mean is a collection, one or more applications to which Kong is sending traffic on a given, that's coming in on a given API. The API is also a Kong concept. So you've configured Kong with an API, and you've told it that when traffic's coming in on that API, send it to an upstream. Then within the upstream, there's typically, ideally, if you're going to use health checks and circuit breakers, you've got more than one target. The targets are multiple instances of the same application. And for reliability, you might have quite a few of them. And with the health checking and circuit breaking functionality, Kong will be checking them, those multiple targets, for health, and should they become unhealthy, it will cease routing traffic to them so that your clients receive more consistent quality, performance, reliability. Now, let's keep the questions coming on Q&A. I'm seeing a few here, and I'm gonna get to some of them here live on the air. Aaron, I think you're getting ready to switch over to live demo. So
yep.
We had a question about Kong populating the load balancer, populating its endpoints or its targets from a service discovery tool like etcd, console. Absolutely, no problem. Kong works well with those. You don't have to declare to Kong the precise instances that are in your targets that are in your upstream. You can instead use tools like that and DNS to populate them. Let's see. We've got here a question about how Kong's health checking and circuit breaking behavior is more superior to a Kubernetes liveness check behavior. So the difference here is that it's much more configurable, and you have much more control over what is considered healthy, right? Kubernetes liveness check is very binary. You're alive or you're not. With Kong health checks and circuit breakers, you get to define alive. You get to define what sort of timeouts, what sort of error codes, how many of them over what time period constitute a down service or an unhealthy target. Even by using the passive circuit breaking, passive health check feature, you can just have Kong observe requests that are being sent to your various targets and look for ones that responses that seem to indicate a unhealthy target and mark that one as unhealthy and remove it from the load balancer. Let's keep going. I'll have a look here at a few other questions here. So we've got a question about how the health check is implemented. We're going to get to that on the demo here. So Aaron, why don't you switch into to demo setup while I have a look at these other ones. We've got a question about does circuit breaking work for function as a service upstreams like Lambda? Well, sort of. So if you have multiple instances, multiple targets in your upstream, then certainly you can use Kong's circuit breaking feature to detect if any of your targets have become unhealthy. But if there's only one instance, well, then no, hopefully it stays up and available.
Okay.
All right. We've got a lot of questions. Keep them coming.
Yep.
And we'll try to get these answered.
Okay. So before I set up the upstream and the circuit breaking functionality, I'm just going to show you what it looks like with a direct hit to my service. So I have a container running on port 80 that serves up HTTP bin. You want it bigger?
Yeah, we'll zoom in a little bit.
All right.
So let's
How's
see.
that?
Okay, great. Yeah. Is that going to be too big?
Well, if I hit this, my proxy port is 8000, remember, and I've set the URI to S1. And if I hit headers, and I'm going to use the -B just to get back the body flag, you'll notice that it hits my service running on port 80. You can tell that by the host value.
Okay, so let's talk a little bit about what's going on here. So Aaron's using a client, a command line client called HTTP-PI. Is that right?
HTTP-PI, I guess.
HTTP-PI. We like it a lot. It's a lot like curl. We think it's better. We think you'll like it too. He's using it to make a call to port 8000. That is Kong's proxy port. So that's Kong listening for incoming traffic. Then that call is to S1/headers. Now the S1 is telling Kong, no, it's been configured with a API that looks for that S1 and routes it upstream to an instance of HTTP bin. And HTTP bin is a nice tool for testing and demoing HTTP calls because it gives you lots of functionality, like if you call it with a /headers, then it will return to you the headers of the call, so you can see them right there, visible. Makes it easy to do. So frankly, our upstream service here is, not giving us stock quotes or weather forecasts. It's just echoing back the headers of our requests, but it's perfect for demoing.
Yeah, and we love it because it focuses in on, API characteristics that we all care about, right? So, bodies, headers, and things like that. What I'm going to do now, just to show you what happens if I stop that service, is I'll just shut down that container. And now when I recall this, it's going to fail because, obviously the container's down, right? There's nothing running on port 80 anymore. And whether I hit that through the proxy, which is going through Kong, or directly through the service, it's the same result, right? I get a connection error because the service is down.
So let's see. So you've had 2 containers running, and is that right? No, you had one.
I actually have 4 containers
of your HTTP bin. Okay, and you've taken one down and verified that when it's down and you try to call it, you get nothing.
Yep.
Right.
Exactly.
Yep.
So now, let's go ahead and go back into my. Okay. Oops. Go back into my.
Now, while Aaron's digging back into this, I'll address a few questions here on the Q&A. We got a question about what happens if the upstream URL to which Kong is routing requests is already behind a load balancer. That is, Kong sends the request to a load balancer, which in turn load balances across your upstream targets. Well, in that case, you're kind of doing double duty. Part of the point of load balancing, health checks, and circuit breakers in Kong is that you don't need a load balancer in between Kong and your upstream targets. Kong is the load balancer. You get to centralize that functionality, make it easier to manage, potentially make it more performant, maybe make it more configurable, and you don't need that load balancer anymore. So you could simplify your infrastructure and your administrative overhead, maybe get more performance too, by removing that load balancer. Now, if you keep the load balancer, no, Kong can't do load balancing or health checking because the individual instances of your upstream are abstracted away by the load balancer, right? Kong's just sending traffic to the load balancer, and then the load balancer is taking care of figuring out which upstreams to send it to. If that's where you're starting out, great. We hope you consider removing that load balancer and simplifying your operations.
It's actually a good segue into setting up this upstream. So let's see that, right? In action, right? So we're going to set up a new upstream. I can call it anything I want. Let's call it my service.
Now we're using the Kong Administrative GUI, the Kong Manager. This is a feature of Kong Enterprise Edition. We could also be configuring this via the administrative API, but it's a little harder to see what's going on. So we're using the GUI here to configure it.
Yeah. So much faster, with the GUI, definitely. So I've called it my upstream, my service. You'll see it's running there, And before I use it, I actually have to populate it with some targets. So let's go ahead and do that. Because I'm running in containers, you're going to see a little bit of unusual syntax here, but it's basically a way for me to point at the containers directly from another container. So docker.for.mac.
So we've got an upstream, which is a collection of identical services, and we're now putting 2 of those identical services into the upstream. When Kong is routing traffic, it will send it to the upstream, and Kong's load balancing, health checking, and circuit breaking feature will determine which target within the upstream to route each request to.
Notice I'm running one on port 80 and another one on port 8080. So that will let me shut one of them down and then route traffic to the healthy one.
Now scroll down a little. Let's have a look at those 2 targets you just created. There we can see that within this upstream, which is called my.service, we've got 2 targets. These are the 2 Docker containers running HTTP bin.
Say that last 10 times.
The weights here indicate that because these both have the same weight, in a normal arrangement or a normal situation with everything healthy, each of these 2 targets is going to receive basically 50% of the traffic. Over time, 50%. You may see during our demo that it doesn't toggle necessarily precisely back and forth, but certainly over the course of time, these would each receive 50% of the traffic.
Just like flipping a coin 100 times, won't be necessarily every time, head tail, but over a statistically meaningful period.
Now hold on, can we just go back to that for one second? I want to show one other thing. We've got a couple buttons there that people sometimes ask about over on the right, the mark unhealthy and mark healthy and mark unhealthy buttons within the targets. Those are manual toggles that force Kong to consider a given target healthy or unhealthy. They're manual. They have nothing to do with whether the target actually is healthy or unhealthy. But once you click those buttons, Kong then considers that target either healthy or unhealthy, regardless of its actual state. These can be useful for testing and experimenting. That's why they're there.
Yep, good. So in order for me to actually use it in Kong, I have to have a proxied API. So let's set that up. I've already shown you this, and I did that before. But in order to hit my service, I can call it anything I want again, right? So demo service, and then I need to hit a URI. I'm going to just hit the transparent one, and then down here I have to have a URL syntax. So it's http:// and I believe I called it my.service. All right, and that's it. That's all I have to configure. Hit create, and now let's hit that endpoint. So I'm going to go back to my command line. Here I'm going to hit HTTP on the proxy port, and now because it's already set up to hit URI, I can just type headers here. And before I do that, actually I want to make sure I've started my service again to see the load balancing go between it, right? And now what do we expect to happen, right? We expect one service to get hit and then another service to get hit in approximately a 50-50 ratio, right? So, and actually let me add in the B just so we can kind of simplify the output here. Okay, so here we have it running on port 80. That's implied because it's not there. You should see port 8080 show up. Okay, so perfect, right? As I hit this a few times, you're going to see localhost on port 80 show up a bunch of times, then port 8080 show up. So you can see both services kind of interacting here.
And so this is Kong's load balancing functionality, doing a roughly 50-50 balance between our 2 targets within our upstream.
Yep. And now let's stop one of those services, right? Just like pretending, that the server just went down, right? A hard crash. And now I don't have anything running on port 80 anymore. Kong's going to detect that and reroute all the traffic to the winning service, which is running only on port 8080. So you'll see that no matter what I do, I can't get any traffic going to that service because again, it's not running, right? I can show you that by hitting the service directly. You remember I set up S1 before, right? And now if I hit that, it's not running, right? So if I use the load balance service using the upstream and circuit breaking functionality, everything is managed for me. I've detoured all my traffic to my healthy road. Now I can go back in and say, oh man, that service isn't running. Let me go ahead and start that back up again. Now HTTP bin is running again. Now let's hit it again. Kong is going to detect that it's working, and it's going to route some traffic over there. There we go, in just a second. So what have we just shown you? That, you know, health checks and circuit breakers are your friends. They're there to automatically detect failures and route things to a working service. The client that I have, you know, is transparently rerouted to the service that is working, and that gives me some time to go in and fix my backends without my clients really noticing that anything really went wrong.
Now, in this demo, we demonstrated Kong successfully routing around a completely down target within an upstream. The health checking and circuit breaking functionality can also consider other aspects of your upstream that might indicate unhealthiness, slower response times, particular error codes being returned, TCP level errors. There's a quite configurable way, plus a certain number of those situations in a given time period. All of that is highly configurable, and it depends on your situation. How generally healthy are your upstreams? Or do they have, you know, your targets, sorry, do they have any sort of built-in recovery mechanisms? Maybe if, you know, they know they're unhealthy and they recover themselves within 5 seconds, you don't want Kong to detect them as unhealthy within 2 seconds. You'd want to give them a little bit longer to recover. And all of this is highly configurable within Kong. So we've got a few more questions here coming in live. We've got a question about Kong's load balancing. The way load balancing currently works is that Kong is dividing up traffic across the targets within a given upstream. Now, the upstream has to contain all of the targets, but you don't have to declare the targets to Kong explicitly. You can also use service discovery tools to inform Kong about what targets exist within an upstream, and Kong will do the right thing in terms of load balancing across them. That typically uses SRV records within DNS, and that feature's been around for a while. The new feature we're showing today is that the healthiness of the targets within the upstream can be detected and responded to appropriately by Kong, by its load balancer. There was a question about, do we have to add the service on a new node every time? I think that's about, you know, do you have to declare all of your targets within the upstream? And no, you don't. You can use service discovery tools that Kong works well with to declare all of the targets within the upstream. We don't have a good demo of that for you today, but good suggestion for a future webinar, certainly. Mm-hmm. We also had a question about using Kong as a ingress controller for Kubernetes. So my understanding is that today, out there in the world, created and maintained by Kong's amazing, incredible open source community, there is a Kubernetes ingress controller, but I can also give you a little preview. We have been working hard on an official one, and we look forward to releasing it soon. So there'll be officially support for using Kong as a Kubernetes ingress controller. Let's see. What are some other questions I should cover here? Keep those questions coming. So we had a question here about, can a Kong load balance general HTTP traffic like web requests, or is it somehow specific to APIs? You bet. Web requests are kind of API calls, right? They're a call from a browser client to some sort of back-end service for some sort of asset or computational functionality. Absolutely, it can work well. And so is this a replacement for application load balancer or HA proxy? In some circumstances, yes. And you know, part of the point of this new functionality is to reduce the necessity for multiple layers and instead bring it into a more consistent, unified place right here within Kong. So yes, we think so most of the time, but we'd be interested to hear from you if you find that you were hoping that Kong was going to be able to do load balancing and health checking for your web requests, and you find that it can't for some reason. Please hop on our Kong Nation community site, which you'll find at via konghq.com/community. com URL. Sorry, that top URL is actually konghq.com, though konghq.org probably gets you there. So konghq.com has a great community site where you can visit, ask questions, provide feedback, and this is the sort of feedback we'd love to hear there. Let's see, we've got some other questions here, less related to the, hey, look at that, live editing of the slides. Less related to today's topic, but let me address them. We've got some time here. Someone asked about request and response transformations, and indeed, Kong does support those. We have plugins for that. And also some questions about sidecar functionality and release timeframes. Well, you're going to start to see some of what you need for running Kong in a sidecar mode in the very next major release of Kong Community Edition. That's Kong CE 0.13, which is coming in a few weeks. That release will also include the new routes and services entities that will start to replace the old API entities and should go a long way to making Kong simpler to configure and manage. So look for that in a few weeks, and likely we'll be having a webinar, a demo for that. We also got a question about using open source plugins with Kong Enterprise. You bet. Kong Enterprise ships with all of Kong's, the Kong Community Edition bundled plugins included, plus a handful of enterprise-only plugins. But all Kong plugins can be used with either edition, Community Edition or Enterprise Edition. At least typically, Enterprise Edition has some functionality. I guess in theory, additional functionality. In theory, you could write a plugin that only works with Enterprise Edition and release it as open source. We don't know of any yet, right? So yes, the short answer is yes, you could use open source Kong plugins with Kong Enterprise Edition. So if you're interested in talking to us about Kong Enterprise Edition, we encourage you to give us a shout. There's a request a demo form on our website. You could also email sales@konghq.com. You could see that down in the bottom right corner. We'd love to get into some more details, give you a personalized demo, answer your questions directly. Let's see. Let me see if I have a few other questions that we can cover here. Keep those questions coming. We'll try to get to them if we're not live on the air, at least via our sales engineers and customer success staff that are joining us. Thank you so much, gentlemen and ladies, for helping us out on this webinar. Just as a reminder, the webinar is being recorded. We'll be distributing a recording afterwards. And in a few weeks, typically roughly monthly, we'll be giving another webinar. Do we know what our next webinar is about yet?
We actually don't.
No.
So I'm open to suggestions. I mean, we try to make it on new features and functionality that just came out. So, you know, if we've got something interesting to show people.
Well, we'll have a big expansion of our vitals monitoring and analytics capability in the next version of Kong Enterprise Edition coming out in a few weeks. So I wouldn't be surprised if we show some more about monitoring and analyzing Kong's behavior and performance using vitals. Here's a quick little preview, but wow, you're going to see some amazing stuff in the future here when it comes to vitals. Let's see. We're getting a few questions about using Kong within Docker Swarm. Indeed, we've used it quite a bit internally, and our understanding is the service discovery part of it for routing to targets within upstream works just as well in all of the container orchestration platforms. Let's see, a few other questions here. Let's see which ones of these can I answer. There's some questions about our analytics and monitoring feature, integrating it with other analytics and monitoring platforms. You bet. What you're seeing on screen right now is some of our early UI around our vitals monitoring feature. But this dashboard that you're looking at, it all runs on top of Kong's administrative API. Everything you can do with Kong, you can do with the administrative API, which includes retrieving these metrics, and then you could send them on to whatever monitoring, alerting, metrics aggregation system you have in mind. And we've carefully designed our vitals analytics API to provide the right sort of shape and format of data for easily importing into third-party systems. All right, I think we're getting close here on the ends of questions, so keep them coming. Aaron, how about we wrap up the webinar here? We'll leave the Q&A feature open for a few minutes in case folks have more questions.
Absolutely. Yeah.
Thanks so much for your great demo of load balancing, health checking, and circuit breaking within Kong. We encourage you to give it a shot. It's available today in Kong Community Edition. We'd also be happy to demo it for you in Kong Enterprise Edition. Just get in touch with us at konghq.com/enterprise or email us, sales@konghq.com. We look forward to you joining us again in about a month for our next webinar. So thanks for joining us today. Thank you, Aaron.
Thank you,
CS and SE folks, and our producer, Maria. We really appreciate it. Take care. See you next time.